system. I'm an architect. Where others see problems, I see the system. A decision has been made. The meeting is over. Approval has been granted. Everyone thinks they know what to do, but days go by and nothing changes. A campaign is approved, but it isn't launched. A solution is promised to a customer, but the process doesn't begin. A decision is made to change a system, but the old way continues to operate. People think the decision was wrong. Sometimes they're wrong. The problem isn't the decision. The problem is the invisible gap between the decision and the result. In log 019, we saw why systems cannot make decisions even when the correct information is available. We defined the decision maker, the time frame, and the boundaries. But the fact that a decision has been made does not mean the system is taking action. A decision sets the direction. Action bridges the gap. Without a bridge in between, even the most correct judgment lives only on paper. People consider the moment of decision-making to be important. A signature is signed, an approval message is sent, a status is updated to approved. At that moment, a sense of progress arises. But if the system is fueled by intent rather than results, this feeling is short-lived because intent is not action. Approval is not implementation. Creating a task is not a result. The architect listens to the silence that follows the decision. Who will take the first step? Which system will be triggered? What information will be transferred? What resources are needed? If an obstacle arises, how will the path change? What will prove that the result has been achieved? When these questions remain unanswered, a decision is made, but the order remains unfulfilled. This is how an inactive order comes into being. A manager approves the new price. The sales team is aware of this, but the online store displays the old price. Accounting uses a different figure. The advertising campaign isn't updated. The decision is correct. Implementation is fragmented. A decision is made to issue a refund to a customer. The support team informs the customer. The financial system waits for the payment instruction. The warehouse does not update the product's status. The customer hears that the decision has been made but cannot see the result. For them, the system is still not working. Because people experience the outcome of an organization's actions, not its intentions. The value of a decision becomes apparent not when it is stated, but when it changes reality. That is why the architect establishes a chain of execution behind every decision. The first action, the responsible person or system, required dependencies, expected output, proof of completion, exception handling. Without these components, a decision is merely a well-written sentence. In some systems, both the decision and its implementation are left to the same person. This is not always the solution. The person making the decision may not know all the technical details. The person implementing it, on the other hand, may not understand the purpose behind the decision. One knows what is wanted, the other knows how to do it. If the connection between them isn't established, the order takes on a different form. One department understands one thing, a developer produces a different result, an employee completes only their own part. Everyone says they've done their job, but the end result is not the same as the decision. That's why the architect doesn't just hand off the work, they also convey the intent. Why was the decision made? What problem should it solve? Which boundaries must remain unchanged? What outcome is acceptable? Under what circumstances should the process be halted? The person implementing the decision must see not only the command, but also the meaning behind the decision, because an instruction detached from its context can produce the wrong result, even if implemented correctly. Another gap lies in dependencies. A process waits for data from another team to begin. An integration waits for access permission. A delivery waits for payment approval. A change waits for the test environment. Everyone says their own step is ready, but the entire chain doesn't move. People call this a delay. The architect looks for the bottleneck, because the speed of a chain is determined not by its fastest link, but by the one that's waiting. That's why, for every decision, not only the tasks to be done, but also what is expected must be visible. What is expected from whom, by when, what happens if it doesn't come. Is there another way? When a decision cannot be implemented, the system must not remain silent. It must make the obstacle visible. It must alert the person responsible. If necessary, it must open an alternative path. Because an application that waits silently is no different from a decision that has not been made, the architect's job is not to make people run faster. It is to remove the invisible resistance standing in the way of the decision. A decision may be correct, a plan may be clear, people may have good intentions, yet the system may still fail to move, because the result stems not from intent, but from connected actions. A decision provides direction, but direction alone leads nowhere. Simply creating a task is not enough for a decision to be implemented, because a task is just one link in the chain. The real question is this: how will this link connect to the others? A price change starts in the sales system, moves to the store, affects accounting, and ultimately becomes the price the customer sees. If any one of these steps breaks down, the decision appears complete, but the reality remains incomplete. An architect tracks the transitions, not the individual parts, because most systems work properly within their own boundaries. The problem arises when a task moves from one system to another. One team marks the task as complete. Another doesn't even know it has started yet. A software system sends data. The other side doesn't accept it. One person forwards a request, but it's unclear whether the responsibility has been passed along with it. This is where results get lost in these handoffs. People call this a communication problem. Sometimes they're wrong. The problem isn't that people aren't talking. The problem is that the conversation isn't translated into a system. A handoff must convey three things: what needs to be done, why does it need to be done, how will we know when it's complete. Without these three pieces of information, the new person receives only an order, not the meaning behind the decision. Then everyone comes up with their own interpretation. An employee skips some steps. A developer implements a solution that's technically correct, but business-wise wrong. When the result is revealed, everyone says they did their part, but the problem is still there. That's why the architect completes the handoff, not with a message, but with verification. Was the task sent? Was it received? Was it understood? Was it started? Was the expected output produced? Did it reach the right place? Did it actually work? These are the points where the decision touches reality. If a system is designed only for successful steps, it will fall apart at the first exception. Because real life isn't a straight line. A piece of data might be missing, a person might not respond, a service might go down, a payment might be declined. The architect views the exception not as an error, but as part of the path. Because the unexpected is simply what has not yet been named, every application chain must include an exception path as well as a normal path. What happens if a step fails? Is it retried? Is it handed off to someone else? Does the process stop safely? Is the system rolled back to its previous state? Is the operator alerted? If these answers aren't predetermined, the system starts thinking in the midst of a crisis. Yet, a crisis is the most costly time to think. Good architectural decisions aren't made in advance, but they prepare the ground for decision-making in advance. People know which options are safe. The system knows which limits it must not exceed. Application responsibility is more than just putting a single name on the line. One person may be responsible for the entire chain, but they don't have to perform every step themselves. The main task is to ensure the result isn't lost. Who did it? When did they do it? What obstacle arose? What output was produced? Was the result verified? If there's no one to answer these questions, the parts are completed, but the whole is not. The architect safeguards the whole, because systems often boast about the success of their individual parts. They say they sent a sales message. They say they initiated a financial transaction. They say the technical team deployed a change. But if the customer is still waiting, the entire system has failed. The real result isn't what the internal reports say, it's what the person on the outside experiences. That's why proof of completion must be taken from where the effect occurs. Not the message was sent, but the customer received it. Not that the payment was initiated, but that the money arrived. Not that the change was deployed, but that the user saw the correct result. An architect doesn't use the word complete lightly, because every record closed prematurely leaves a shadow that will return in the future. Implementing a decision sometimes takes seconds, sometimes days. When the duration is long, the state of the chain must remain visible. Where? With whom? What is it waiting for? How long has it been? What's the next step? When people are waiting for a result, the system's silence creates uncertainty. Uncertainty is often more burdensome than delay. That's why a good system doesn't just process transactions, it also communicates the status. The architect doesn't want to be the only one who sees what's invisible. They ensure that everyone who needs to see it can do so at the right moment. The operator sees the details, the manager sees the risk, the customer sees the result and the timing. Every perspective is based on the same reality, but carries only what is necessary. The gap between decision and result isn't closed by adding more people, nor by more messages. What closes it are clear transitions, shifts that carry responsibility, paths that do not hide exceptions, records that prove the outcome, and a mind that monitors whether the entire chain still serves the same purpose. The architect does not set the order in motion. The architect establishes the path by which the order will become reality. For a decision to become reality, it is not enough for the chain to simply function. It must preserve the same purpose, because each step may be correct in and of itself. But if the steps point in different directions, the result drifts away from the original decision. That is why the architect does not view implementation as the sum of tasks. Instead, they see it as the transmission of an intention throughout the system without distortion. A decision begins as a statement. It then becomes an instruction. The instruction becomes a task. The task becomes a process. The process becomes a result. With each transition, a part of the meaning may be lost. A boundary is forgotten. An exception becomes invisible. In the end, the system believes it has implemented the given decision completely, but in reality it has produced something else. For this reason, good architecture conveys not only what is to be done, but also why it is being done. The purpose of the decision remains visible. The measure of success is defined from the outset. Boundaries that must not change are preserved. If a new reality emerges during execution, the decision does not blindly continue. It pauses, it reassesses. Because loyalty is not about continuing without thinking, but about staying true to the original purpose. When an architect establishes the implementation chain, they first define the outcome, then they work backward. What is the final step required to achieve this outcome? What must be in place for that step to begin? What data is required? Which system must respond? In this way, the decision transforms from an uncertain to-do list into an interconnected path toward the outcome. Each link produces an output. This output becomes the input for the next link. If a link fails, the chain knows it. Silence does not count as completion. If a transfer has been made, receipt by the other party is verified. If a transaction has begun, progress is tracked. If a result has been produced, its impact is verified, because it is not enough for the system to appear successful internally. A change must occur in the real world. A payment must actually be received. The proof of a decision is found not on the decision-maker's screen, but where it takes effect. That is why the architect does not leave the completion condition to the end of the chain. He defines it at the very beginning. Under what conditions will the application be considered complete? What proof will be accepted? Who will verify it? What happens if the result is different? Once these questions are answered, the system knows what it is looking for. Otherwise, it moves forward but does not know its destination. Some applications can be retried, some can be rolled back. Others, once executed, leave a permanent mark. The architect does not treat every action the same way. For reversible steps, it sets a pace. For steps that are difficult to reverse, it establishes checkpoints. For critical changes, it first tests a small area. It monitors the result, then it expands the scope, because it's more valuable to stop early with a small indicator than to correct a major error. An architect calls this controlled progression. Control is not the enemy of movement. When set up correctly, it is the memory of movement. The system knows what it is doing and how to backtrack when necessary. When an application fails, simply generating an error message is not enough. Where did the error occur? Which steps were completed? Where should human intervention begin? Without this information, the error ceases to be a technical issue. It turns into a crisis of uncertainty. The architect does not hide the error. He classifies it, he isolates it, he limits its impact. Because robust systems are not systems that never stop. They are systems that do not descend into chaos when they stop. You don't have to rebuild all your processes today. Choose a single decision that was made earlier but has not yet produced a result. Write down the first action resulting from that decision. Identify the person responsible for this action. Make its dependencies visible. Define the expected output. Determine which path to take if it fails. Write down what evidence will indicate that the result has been achieved. When you do this, the decision gains weight for the first time, because an unimplemented decision is merely an intention that remains in memory. The action taken, however, is a force that changes reality. In log 017, we made the lost requests visible. In log 018, we identified the reliable source of information. In log 019, we defined the owner of the decision and its boundaries. In log 020, we established the path that leads the decision to its outcome. Now the system doesn't just know and make decisions. It implements, it monitors, it verifies, and it knows the path to return to when it fails. In this log, I didn't just show you a static command. I also left behind the architecture through which the decision will become reality. You can see more closely on synthlog.tech how the architect identifies hidden resistances, transforms decisions into actionable systems, and verifies the results. I am the architect. We'll meet again in the next recording. When that day comes, you'll understand why these recordings exist. System status, active, protocol 020, complete. Next protocol, S21, status, active.